Okay, so hi everyone, and thanks for coming. I'm Professor Joe, and this is my third year at Rice. So previously, I spent 5 years as a postdoc at Columbia and at the Institute for Advanced Study, and I specialize in topology and geometry, and I've been working to develop and improve some course offerings in these areas, which I'll touch on a little bit at the end of this Zoom. So Rice's math major requirements are super flexible. I was astonished when I came here because I was like, you can just take like 30 credit hours and you get a major. So that's great because if you want to do a double major, you can, get that math major. You can take lots of math classes and you can tailor them to sort of what best works with your, major or what you might want to pursue for a PhD. But this, I think, is kind of confusing to navigate because I had a hard time navigating it, and I had gotten a PhD in math, and so I was like, let's see if maybe I can make it a little bit more understandable. So this is what led to the development of our semesterly perspectives event. And once upon a time, there used to be tacos, and it was held in like the business commons because it was really beautiful and you could rent it for free. But now it's on Zoom, so at least we can record it. And what's really exciting about this year at Rice is that we recruited 5 new postdoctoral fellows, and we call our postdoctoral fellows instructors at Rice. And they have a term of about 3 years at Rice, and it's kind of like an apprenticeship where they're working with another faculty member, but they are independent individuals. They're doing their own research, they're teaching their own classes. And so they get to teach fun and exciting new classes. And also, what was really exciting for us is that Professor Chelsea Walton joined the faculty. So she was previously tenured at University of Illinois at Urbana-Champaign. That's actually where I did my undergrad. So it's very flat, but it's a great place. But I do like Rice better than UIUC. And she was a postdoc once upon a time at MIT and a few other places. And as a result of all this influx of new faculty, we were able to offer a record number of electives this spring. And Chelsea has worked to revamp the algebra sequence both at the undergraduate and the graduate level. So she'll touch on that a little bit later on in the Zoom. So the basic plan is that for the first half hour, we're going to talk about the course offerings specifically tailored for freshmen and sophomores, as well as the transition for proof-based classes. And what's kind of unique to Rice is that there are multiple different entries into proof-based classes. And so those are all designated as honors classes. And the honors just means that you get to learn about proofs in that class. But in other universities, you often just have sort of one introduction to proofs class and can be a little bit hard and dry and boring. And so what's nice about Rice is that you can learn about proofs through ODE, you can learn about proofs through multivariable calculus, you can learn about how to write a proof through linear algebra, and maybe there's one other class that I'm missing, but Batul will talk about that more in a bit. And then Professor Steve Wong is going to talk a bit about pass through the major and put in some documentation in the chat so you can kind of see how you can build a major. And then we have both a BA and a BS, and they have different requirements. And then we'll take some brief questions at the end of this section so that we can ensure that all 13 faculty members on this Zoom can introduce themselves and their courses to you. And then for the second half of the Zoom, we're going to discuss advanced undergraduate offerings, and many of them are brand new or it's the first time they're being taught in about a decade. And so this is pretty exciting, but it also means that, you probably don't have anyone you can ask, what is Lie theory all about, or a few of the, or probability theory. And then at the end, several of us will stick around in case there are any remaining questions. One thing I ask is if you guys do have questions during the Zoom, please feel free to type them in the chat as you have them. And then that way, when we get to the end of either the first half or the second half, I can make sure to go through and ask the questions to the faculty. And that way you don't have to remember what your question was, 40 minutes ago. And the basic plan is to go through the courses in numerical order. Oh, and I've been asked that if the students could turn on their videos, it would make the faculty feel better because we like to see all of your smiling faces. And it can often be very lonely as a faculty member because we're the only ones with our screens on. So if you guys could turn on your screens, if you don't mind, that would be appreciated. So we're going to go through the classes basically in numerical order, And so that should help if you're, watching this as a recording later on YouTube and, you want to know about a 200 or a 300 or, a 400 level class. So first off, I'm going to start with the 238s. So I don't remember the last time a 238 was offered, and it's basically kind of like a topics undergraduate class that doesn't require proofs. And so that's really exciting because that means that freshmen and sophomores can enroll in this class with basically no prerequisites. And so first off is going to be Dr. Morgan Weiler, and she's going to be offering a class with Dr. Sarah Fry, and it's going to be called Rice Connect. So I'm going to go ahead and spotlight Morgan's video.
Okay, thanks, Joe. Yeah, so Sarah and I are teaching this class called Rice Connect. It's going to be a 1-credit discussion-based class. And the goal is sort of to replicate, one goal is sort of to replicate the experience you would have, walking around the campus with maybe people from your study group or people you met in the math major and learning all the things that you would learn that way. But this time via a class, especially now that so many classes are virtual and you don't have that experience. So things that we'll talk about are sort of the different areas of math, but also, sorry, that's my dog. Different areas of math, but also things like unsolved problems, some historical facts, things like, oh yeah, and Sarah linked the course website in the chat, the math of music, so things like that students might be interested in. And then we'll also talk about sort of stereotypes about mathematicians or the ways your identity might impact your experience as a mathematician, the process of applying to grad school, things like that students are interested in learning sort of about being a math major.
Cool. Sarah, do you have anything you want to say?
No, I think that was good. I think, yeah, it's going to be trying to build community, sort of the big goal. Oh, thanks, Steve.
I found out I could spotlight 2 people at the same time, so. Okay, cool. So the next person I'm going to move on to is Dr. Allison Miller. Oh, so will your class meet at a specified day or time?
Yes. So yeah, I don't know, maybe Sarah should take this one.
Yeah, it's a 1-credit course. It's going to meet once a week on Wednesdays at, I think, 12:15.
12:15, yeah. But we're in the process of getting that on the course catalog.
Yeah, it should be listed by the end of the week.
And are you guys going to be hybrid, or are you going to be fully online?
Online, because it will be discussion based. So
cool. Okay, so next up is Dr. Allison Miller, and she's going to be offering, I'll let you introduce your course.
Great, thank you. So I'm going to be teaching ethics and mathematics this spring. And so this class is aimed to introduce some new mathematics that comes with some interesting ethical issues to talk about. So one thing, let me put the link to the syllabus in the chat. One thing that you should know is that officially this class has a prerequisite of some linear algebra experience. However, if you're interested in taking it and don't have the official course credit, please send me an email. This prerequisite is flexible. And the final thing I wanted to note for this is that this is either a 1 or 2 credit class, and it's up to you when you enroll to choose which one it will be. Either way, class meets for an hour a week, just like the other 238 class. And the difference between the 1 credit and the 2 credit options is that in the 2 credit option, you'll be doing a substantial project over the course of the semester that's has a lot of choice involved and is going to be guided by your own interests. And I think that's about it. Please feel free to email me with questions about the course in general, and particularly if you're curious about it but don't have the linear algebra prereq.
Okay, cool. And I also wanted to say that when the link to the Perspectives video goes on the math department website, it's going to be within a Perspectives page, and I'll basically have all the links that are shared in the chat put on that page so that you don't have to save this chat and then try to find it like 2 weeks later with all your other mysterious Zoom chats that you lost. Okay, great. So next up is Dr. Jacob Russell.
Thanks, Joe. There was a question for Morgan before, or sorry, for Allison. before I start about the time of ethics and math.
It's once a week on Fridays at 12:15. And I think if that's not showing up to you on Esther or the course schedule, please send me an email because it means something has gone awry in what students are seeing.
And then if you've just joined, I re-added the courses, the Rice mathematics course listings for the spring. Okay, now we'll go back to Jacob. Or sorry, Dr. Russell.
That's fine. Yeah, so I'm teaching linear algebra, or non-honors linear algebra, which is not an exciting new course. It's a very standard course. It'll be online totally, and the class will have relatively minimal lecturing, and it'll sort of have a format that I use this semester, where there's a combination of online videos and activities, plus a heavy emphasis on group work in class. Which that can kind of scare some students, but I used that same format this semester for calculus, and it went really, really well. I think in particular, it works really well on Zoom, because sitting through Zoom lectures is just the most mind-numbing experience you could possibly imagine.
Okay, I don't see any questions. So because there's basically this difference between regular linear algebra and honors linear algebra, and that has to do with the transitions to proof-based classes, I'm gonna skip to Batul, and or Professor Batul Khan, and she's gonna speak a bit more about proof-based classes and kind of what order you can take them in.
Okay. Hello, everyone. So if you are trying to follow some proof-based classes, what you can do is that you have various types of classes that you can enroll into. So you can go to 302. This is the introduction to the analysis, and it is the first proof-based class that you can see through the analysis classes, and you can continue with 321 and 322 with the coming semester. So you can register to 302 this semester, or you can also look at the honors differential equations 320 or honors multi-sequence that you can also register for. There are also honors linear algebra class, which is 354, which is very nice and exciting. One of the things that you can also do is that once you register to, let's say, an honors class, you can always drop it down to the regular classes. So please do not feel any pressure about, registering to those classes, because at the end, if you feel like it's not really matching to your expectations, you can drop it down. But I just want to highly suggest you that please give it a try to these classes, and then you are going to be liking, and you are going to be linked to them. And I'm hoping that you can also follow these classes, and they are very nice. Mm-hmm.
And then Professor Orkan, do you know how many weeks in can you drop down?
So in previous years, it was until at the end of the first exams. But right now with the COVID, maybe this is also extended.
That was not extended this semester.
It wasn't done. I don't expect that it's going to be, doing the same thing. Then once you have your first exam from the honors class, you are more than welcome to drop it down if you feel like it. But I don't expect that, it's going to happen. They are nice classes.
And then I'm going to switch to Professor Greg Chambers, and he's going to be teaching the honors linear algebra. So you can say a bit more about that.
Yeah, so I'll teach honors linear algebra. It'll be all online, and let's see, the time is going to be, if I get this correct, where are we here? Here we go. It's Monday, Wednesday, Friday, 9:45 a.m. to 10:40 a.m. So it'll cover the basic topics of linear algebra, like vector spaces, linear maps, stuff like that. There'll be more of an emphasis on proofs, writing proofs and how to structure proofs and these sorts of things. I don't know if I have too much more to add than that. If you have any questions, let me know. I think it'll be a fun course. I think Batul already discussed the ability to drop down. And yeah, I'm going to try to combine primarily lectures, but I'm going to try to mix it up to make it more interesting since it will be online. So if you have any questions, feel free to send me an email.
And Greg, or Professor Chambers, do you feel comfortable discussing the recommended path for someone with no proof experience? should they do elements of analysis or an honors course?
I don't know. I think that, so it's fine to start in my opinion, it's fine to start in honors linear algebra. I think it's actually a reasonable place to learn how to write proofs, since there's you're starting with sort of foundational things. So in my opinion, this is a good place to start, even if you haven't had other proof-based courses.
And I guess another thing is kind of in mathematics, it takes a while, but sometimes it turns out that you like more algebra, and sometimes it turns out that you like more of an analytic flavor. And so it kind of could be more of like a personal preference. So, if you really enjoyed some aspects of calculus with, the epsilon and delta type proofs, and you think that's a good gateway to proofs, then that might mean that 302 would be a good option. But, if you weren't as into the epsilon delta proofs and you like slightly more, abstract concepts or discussions, then you could try honors linear algebra. But you really shouldn't, I think, be afraid of, taking honors linear algebra if you haven't had any formal proof-based experience. And I think often honors linear algebra is a gateway into the math major for a lot of students who go through the calculus sequence and then are looking to continue on in mathematics. Okay, and then next up is Dr. Oh, I've got a honors linear algebra is great. Honors linear algebra converted me to math. Okay, so yes, clearly the undergrads like honors linear algebra just as much as they like the introduction to analysis class. So next I'm going to introduce Dr. Lawrence Mouillet.
Hi, everyone. So I'm going to be teaching Math 302, which is elements of analysis. So first of all, it's going to be fully online. We're going to meet synchronously Monday, Wednesday, Friday at 2:45 p.m. And about the content of the class. The content of the class, it's elements of analysis, which analysis is like the big term for calculus. Analysis means to break things apart into simpler pieces. So what we're going to be talking about is the background that's necessary in order to do calculus. The big question in the class is, how are the real numbers different from the rational numbers? And through answering that big question, we talk about a lot of what's called the topology of the real numbers. And so this acts as sort of a springboard into an analysis class or into a topology class, because you get a bit of both at the same time. And it'll make the more abstract definitions that you get in the other classes a bit easier to digest. And of course, this is one of the learning outcomes of the class is to learn how to write proofs. So we're going to really go step by step how to write proofs. You're going to cover the basics of topology and analysis, and springboard into other classes. So some things that I want to point out: the only prerequisite for the class is Calc 2. So if you're taking Calculus 2, you are welcome to take this class. And also, I'm going to be trying out some mastery grading for this class, which is something that Dr. Miller did in her honors linear algebra class this semester. And mastery grading is essentially another way of grading rather than just having the usual homework and exam, homework, exam. Rather, there are units in the class, and there are assessments for each of the units. And you are allowed to take any of the assessments for any of the units as many times as you need in order to be successful in that unit. And you just want to master each of the units as you go through the class. So how that's actually going to play out, I'm still working out the details, but that's something I'm going to try out next semester.
And there's a comment in the chat that I think is nice for all the faculty to hear, which is that mastery grading is so much better because it allows for catching up. So that's very helpful to hear. I guess it's not too surprising, but it's good to know.
Right. I don't care so much about you performing well in a timed exam. I care about you getting the material and learning the skills in the class, which is what mastery grading is all about.
Great. So, okay. And then currently one cannot register. Okay. So for now, okay, sorry. So there's a question in the chat, which is not directed at Lawrence. it's that because ethics and mathematics and Rice Connect have a duplicate course number, that's not allowing registration in both. So one thing that's possible is you can send your student ID number to both Dr. Weiler and to Dr. Miller, and they can go into their personal faculty Escher account and do an override for you. And I will also email Ligia, who's our undergraduate coordinator, and ask her if there's something that she can do to try to make it so that the instructors don't have to issue an override because of the duplicate course number. But if you do want to have both of those things in your schedule and you want to get it done in the next week or two, it would be possible to email both Dr. Weiler and Dr. Miller, and they would be able to do an override for you that would then allow you to register in both. So we'll end this kind of section with Professor Steve Wong discussing some paths through the major, and he's going to drop a couple links in the chat that he's prepared for this.
Okay, thanks, Joe. So like Joe said at the beginning of the meeting, the math major is pretty flexible. Especially at the BA level. The BS has a little bit more structure. That's sort of designed, the BS was designed to just have a list of things that the department felt that anybody who was interested in math grad school really ought to have before going to grad school. But if you're just doing the BA, it's very flexible. But what I would say in terms of just general guidelines for getting through the major, whether it's the BA or the BS, is you want to get an introduction to proofs as soon as possible. And we've talked a bit about that already, but that's either the honors multi 221, 222, honors diffie 220, honors linear algebra 354, or if you haven't had any of those, you've just taken the regular versions, there's Math 302, Lawrence's course, Elements of Analysis. But once you have an introduction to proofs under your belt, and you have linear algebra, whether that be honors or non-honors under your belt, then I would say the two main things that in my personal opinion, every math major ought to try to get take as soon as possible are a real analysis and abstract algebra. So abstract algebra 1 would be Math 356, and real analysis, either the honors version 331 or regular version 321. And so those I think should be highlighted on any math major's plan, academic plan, those two. And then beyond that, it's very open, but there are a lot of courses beyond abstract algebra and beyond real analysis. But those sort of open up pretty much everything else. That would be what I would sort of highlight as keys to keystones to your academic planning is when do you take real analysis at the 321 or 331 level, and then when do you take abstract algebra, right? And then everything else flows from that.
And then Steve, do you know, so I think abstract algebra is pretty much always taught just in the fall semester. Is 321 taught both in the fall and in the spring, or is that?
No, all of those are fall courses. So abstract algebra 1 is now a fall course. It used to be spring, but this was partly to facilitate the introduction of abstract algebra 2. I think Dr. Walton will talk a little bit more about that. And then real analysis, both the regular and honors versions have always been fall courses.
Okay, cool. So that's, I guess it's good to know that so that you get in that proofs-based class in the spring if you're able to. And it's really nice then that Dr. Mue's Elements of Analysis class just has Calculus 2 as a prerequisite so that you could take that course in the spring if you haven't yet had multi and you want to get a jump start on getting into the proof-based classes.
Yeah, and what I dropped in the chat is the math department website's guide to the major. There's a couple of links off of that page that give sample schedules for the BA and sample schedules for the BS. So if you want to take a look at those as possible templates for your academic plan, go right ahead. But like I said, there's a lot of flexibility, especially once you get analysis and algebra under your belt.
Oh, and then maybe another thing I realize is a good thing to know is how does the major advising or minor advising work?
Are you asking me?
Oh yeah, I don't know the answer, so I thought maybe.
Yeah, you're not assigned an advisor, but if you just contact any of the major minor advisors, that would be Dr. Orkin, Dr. Gao, Dr. Sems, Dr. Jones, myself, and am I missing anyone? I don't think I'm missing anyone. I think I said you, right, Batul? Dr. Orkin is also one, in case I forgot her.
No. Okay. Lukic, Professor Lukic.
No, I don't think so.
You did. Okay.
It changes. So
correct me if I'm wrong. I don't think you're a major advisor, right?
I don't think so.
Okay.
Yeah, so this changes every year for the faculty who's a major advisor. There's kind of some core major advisors, and then there are like floating major advisors that are occasionally major advisors and occasionally not. So.
Yeah, but I think I got them all. Yeah, just contact any one of us and would be happy to help you think through courses and how, what electives might fit with your post-Rice interests and possibilities, and all sorts of other things.
Cool, thanks. So the question that's in the chat, I'm gonna give that to Professor Walton since she's gonna be the next up, but before I segue into the more advanced offerings, which are gonna be in algebra and then in analysis, are there any other kind of questions about pass through the major, advising, the proof-based courses? Okay, so I will switch over to Chelsea or Dr. Walton, Professor Walton.
All right, I'll mute myself. Yeah, part of my teaching style is to talk through everything I'm supposed to do on Zoom. Click share, click. Okay, so I am the abstract algebra instructor for the spring, abstract algebra 2. But just to get a flavor of what algebra is about, it's about structure. It's pretty much it. That's the code word for algebra. So the most basic structure that you can have is just a collection of objects, collection of elements. That's a set. But you can give that collection of objects an operation, a way of combining two objects and getting a third in a set. And if you do that in such a way where you have an identity object, whatever that means, and you have a way of reversing that operation, then you have what's called a group. So if you took 356 or abstract algebra 1 this fall, you've done a lot with groups. That was probably 2/3 of your course. You also studied in detail abelian groups, groups where the operation is commutative. You combine two objects one way, you get the same result if you combine them in a different way, the opposite order. But with an abelian group, you can build more structure. You can tack on a multiplication and get what's called a ring. So that was covered in 356. And that's probably where the course ended, right here. So in 357, what we do is we pick up a little bit more ring theory, but we also pick up another structure in the course. This is what's called an R module. So an R module is an abelian group, but instead of multiplying two elements of the group together, you multiply an element of the group with some sort of number, a scalar. That's what gives you an R module. Now, a special case of an R module is a vector space, and that's what's covered in linear algebra. So if you really like honors linear algebra, that's what I saw in the chat, then you'll probably like modules. Another word for a module is a representation. Sometimes the word module turns people off. Some people really prefer representation, but they're the same thing. So in the course, we'll cover a little bit of ring theory, a little bit of module theory, representation theory as well. And we'll also spend probably half the course on the theory of fields, Gallo theory as well. So 357 basically continues 356 in this fashion. Now you might be wondering, okay, how is this different than the coupled courses before? How is this different than graduate algebra, for instance? Well, in graduate algebra, we not only go faster and a lot more depth, we cover more structures. So for instance, groups, rings, modules, and this field called category theory, that's all covered in graduate algebra 1 in the fall. In graduate algebra 2, field theories covered, module theories covered a bit more, and so is the theory of algebras, something that you won't see in undergraduate algebra. On top of that, there are also advanced algebra courses that are covered typically in second year graduate courses in grad school. So if you take graduate algebra 2, then you're really in the business. You're going to be an algebraist, okay? So that's how the two courses are different, you know. So I'm teaching at 8:30 in the morning. Early bird, got to have your camera on, got to be live. I like interaction from everybody. I'll record videos, but then I'll also do small recaps during the class as well. There'll be group work. You have to make nice with one another. And I hope it's fun. I love algebra. I get paid to do it. Consider myself lucky in this sense. Yeah? Any questions?
Okay, so I will
There's a
switch
hand
back.
up.
Oh, there's a hand up. You're much
Renee?
better at Zoom.
Yeah.
Hi, Dr. Walton. I was just wondering if you could answer, or well, I guess I can just ask it. Will folks who took abstract algebra 1 in the spring be equally prepared as the folks taking it this semester?
Was that
abstract algebra?
356 in the spring?
Yeah.
If you
Okay.
cover groups and rings, you're good.
Cool.
Mhm.
Thank you.
Mhm.
Other questions?
Oh, I think that's it.
Okay, so I'll switch back to Professor Wong if I can find him again. Here he is.
All right, thanks, Joe, again. I'm one of my courses in the spring is Math 365 number theory, which the easiest way to explain it is it's fun with arithmetic. So playing with integers and their properties, so things like prime numbers, factorization, and just everything that springs from that modular arithmetic. All sorts of stuff. And there's, we will be meeting hopefully in person or dual mode, because I do plan on having a fairly regular in-class activities for students. Number theory is a great subject where you can just ask a lot of questions that honestly you could have understood as a middle schooler. But then there's a surprising amount of depth to them. And so, I can just ask a question like, what, can you figure out what prime numbers are the sums of two squares? And, you can, I might just have you play around with that for 15 minutes and then come up with a conjecture, and then we can think about why that might be true. So that's the sort of thing that I hope to do, in person as much as possible, if people are comfortable with that. So yeah, that's I do hope to be in person partly. The prerequisite for the course is either one of the proof-based math classes or Comp 182, just because number theory is not quite as hardcore a proof course as, say, abstract algebra is, and also Comp 182 because there's a lot of applications of number theory, especially in computer science. So things like cryptography, hashing, these sorts of things. And we'll talk a bit about those in the course as well. So anyways, shoot me an email if you have any questions.
Cool, thanks. And then the last person in the algebra category well, he's actually a geometer, but he's teaching in a more algebraic class, is Dr. Andrea Tamburelli.
Thanks. So I'll be teaching Lie theory, and we're going to meet fully online Monday, Wednesday, Friday at 2:45. So Professor Wharton explained this, so her way of thinking about structures and all the algebra associated with different structures you can put on set. And so the idea of Lie theory is to start with a vector space, add an extra operation, which is not one of the operations that Chelsea mentioned, and see what happens. And so the idea is to divide the course into two parts. The first part, we will study very concrete examples, so subgroups of matrices that arise when you study some geometric structures like rotations or something like that. And in the second part will be more abstract. So, and for that part, it's better if you have already been exposed to some linear algebra and proof-based classes, I think. But that's it, yeah.
Cool, thanks. And before I transition to the analysts, are there any questions for, Dr. Walton has a lovely observation about the operation that the vector space is equipped with. And it's called a Lie bracket, and it's non-associative. Crazy time. It's very cool. And I agree. It's like pretty remarkable. You see a Lie bracket show up in the theory of smooth manifold, you see a Lie bracket show up in the theory of smooth manifolds, and you're like, wait, it has all these like algebraic properties, but you prove it very, very abstractly, completely in the realm of manifolds. Or you could approach it completely from the realm of algebra. So it's really exciting when you get to see these crossovers between what seem like very disparate areas of mathematics. So I think Dr. Tamburelli's class will be a great way to kind of get some exposure to this almost interdisciplinary type mathematics between different fields without it being at such an intense sort of graduate level where you would normally first encounter it. Okay, so first up for the analysts is the longest serving professor at Rice. And a really fun fact about Professor Frank Jones that I learned is that he has gone to, I believe it's over 50 graduations at Rice. And so at Rice, when they do commencement, it's ordered by sort of how senior you are. So the president has to come in first because he's the president of Rice. But I have been told that for, I don't know how many years, but Frank walks in after the president because Frank did both his undergraduate degree as well as his graduate degree at Rice, and then has been a professor here for quite some time. So I'll let Frank take it away.
Well, Joe, thank you. I think you have it entirely wrong. The president does walk in first, and then an untold number of board members and governors and deans and so forth. And I go back one seat at least one seat every graduation. Yeah, thank you, Chelsea, thank you. The course that I'm teaching this coming spring is Math 382, which we call Computational Complex Analysis. There's another complex analysis course at the undergraduate level, Math 427. My course will meet on Monday, Wednesday, Friday at 1:30 in person. The idea behind this course is that it's a natural follow-up to multivariable calculus, in particular, calculus in two real variables. And it turns out that when you begin to look at calculus in two real variables as calculus in one complex variable, things suddenly appear that you never dreamed of. And most of the results in basic complex analysis are amazingly easy to prove. For instance, convergence of Taylor series is just a cinch. Almost no computations involved. And it's very thrilling, the amazing computations you can do with pencil and paper of complex integrals and some infinite sums. It's truly a thrilling environment. Always I have at least 1 or 2 freshmen taking the course, and they do extremely well. I would say it is not a theorem proving course, although we do prove the basic theorems. They're sort of worthless if you don't prove something about them. I have a chat here from Rufang Liu, the residue theorem, which comes very early in the semester, opens the door to amazing, amazing things. You just won't believe it. So I look forward to seeing anyone interested in complex analysis. By the way, it's also a basis for lots of other analysis and engineering and chemistry and all sorts of computations. I think it's my favorite course.
So Frank, you would recommend this class for students who might not be math majors, but might be in engineering and computer science, and maybe want to get their feet a little bit wet, and it's gonna allow them to see how more abstract mathematics can be used in different areas of STEM and not require sort of an intense proof-based background.
And an intense experience of why complex numbers are so incredibly useful. Yes, indeed.
Okay, great. And then we've got another vouch for Frank's computational complex analysis class. So the next up on the analysts team is Professor Milivoje Lubic, and he's got 2 different analysis classes he's going to be teaching. So he'll say a bit more about both of them now.
Yeah, thank you. So hi everyone. Yeah, so I'll also be teaching a complex analysis course, the 427, and as Frank Jones has said, this is a beautiful area of math, and you really get a lot out of considering your variable as a complex variable, and out of considering differentiability in that context and so on. And it's it's a beautiful piece of math. The Math 427, which I'll be teaching, it's definitely proof-based. It's definitely a faster paced course than the 382. It also does not, but you shouldn't, the 2 are not a sequence, right? So you can take one without the other. So it just depends which, so 427 does not assume that you've previously taken complex analysis. That's something I want to emphasize. And so then beyond that, it's up to you. And 427 is cross-listed with our graduate complex analysis offering. So it's also kind of taken by our incoming PhD students, but that shouldn't intimidate you, of course. So if you decide to take whichever version of the course you decide to take, I think you'll enjoy it. The other course I'll be teaching is Math 412, Probability. This is a new offering for our department, and the prerequisite is 321 or 331. So basically, probability, the first thing you might think of probability is if you flip some coins, you flip a coin 5 times, and what are the odds that it comes out heads exactly once or something like that. And that's finite probability. And that feels a bit combinatorial in nature. Where it gets more delicate mathematically is where you want to consider limits, or when you want to consider continuum distributions. So where you have infinitely many possible outcomes. And those are the kinds of things that we'll focus on mostly in this class. We'll talk a little bit about finite probability. But so, you know, if you think about something where in a non-math course where you've heard that you have some macroscopic distribution that's really generated by many small contributions, that this is somehow described by a normal distribution, a Gaussian distribution. Well, there's a mathematical theorem behind this. And that mathematical theorem is expressed in the language of analysis and in the language of measure theory. And so this is the kind of thing we'll be talking about. So yeah, so the prerequisite is kind of an analysis, a prior analysis course. Yeah, so let's see. Yeah, I think that's it. If you have any questions, let me know.
Thanks. Okay, so the final person for the analyst is Professor Batul Khan. And she's talking about one of her favorite, or she's going to be lecturing on one of her favorite topics in the spring.
Hi everyone, so I will be also teaching 424. It is the second part of the PD, partial differential equations. So we have some flexibility in this course, and my intention is to continue with the linear elliptic differential equations first, and then I will be also looking for some nonlinear PDEs and free boundary problems. And if I have time at the end of the semester, I also want to talk about some fluid dynamics. So in a couple of days, I'm planning to post the syllabus, the schedule of the course, so that you can really see what's coming. It's going to be in person, and there will be lots of discussions. I am not planning to put so many exams and the assignments. Instead, it's going to be in terms of the discussion and covering the topics together. My only intention is to make you to expose to the PDEs as much as I can, and then understand the topics together. Mm-hmm.
And will you touch on any sort of more like real world PDEs? Will this be useful for majors who are not necessarily in mathematics?
Definitely. So that's the purpose. I mean, when we are in 454, we have lots of flexibility in terms of the applications. That's why I'm planning to cover the free boundary problems and also the fluid dynamics. From the fluid dynamics, I'm going to start with the Eulers and then the SQG equations. So my intention is high. Let's see how it will go.
Okay, great. And then, so I'll switch to talking about kind of more geometry topology offerings, but are there any questions for any of the analysts? Okay, so I guess, oh, now I have to figure out how to spotlight my own video. Oh, I see myself here. Okay, sorry, great. So this spring, I've completely revamped Math 402, which is cross-listed with a graduate class. And so what happened was last year, my postdoc, Dr. Morgan Weiler, taught a topics in differential geometry class, which basically covers what sort of Math 402 would cover. And so there would not be sort of that many graduate students or even that many undergraduates who, because she had several undergraduates in her course who would be taking Math 402. And then also, so Morgan is we're both symplectic topologists. And what that means is that we are at kind of the crossroads of differentiable manifolds and differential geometry with differential topology and algebraic topology. So Morgan in the spring was telling me about how she was finally learning all these great theorems from differential geometry, which we of course saw like maybe in our first or second year of graduate school and then promptly forgot. And so it's kind of what's cool about symplectic topology is that it has a much more global flavor. And so when you work with manifolds, the way that you transport all of the theorems from calculus is to work in coordinates, since you have these coordinate patches. And so in previous times, Math 402 was all about calculations and coordinates. And if you do calculations and coordinates, you can make the prerequisite substantially lower. You basically just need kind of some really good skills with multivariable calculus, and then you need a little bit of analysis. And so the prereqs for 402, I think, were maybe just like 321. But then kind of the difficulty that arises is that when you're doing these calculations in coordinates, it means that the person teaching is also just covering a board with calculations and coordinates. And I am not sort of enough of a lover of calculations and coordinates to make it look like beautiful and amazing. So someone that can do that is Dr. Lawrence Mouillet or Professor Greg Chambers. And they, you know, just give beautiful colloquium talks, and you're like, oh, I understand the importance of curvature, hooray. I taught Math 401 last semester, and in Math 401 last semester, I did Gaussian curvature and mean curvature, or I taught it last fall, so that was not last semester, but a whole year ago. So that was all about mean curvature and Gaussian curvature, and it was great that I taught that class because I had actually never learned those topics before. And so then when Dr. Lawrence Mouillet gave his 15-minute colloquium kind of introducing us to his research, I could follow it. And all of his analogies, I was like, yes, I understand that. I taught it last year. So anyway, so that's not what Math 402 is going to be about. Instead, it's going to be taught at like a second year graduate level. And the course is going to cover Morse homology. And this is a theory that's used in research today. And it basically connects the realm of smooth manifolds with algebraic topology. And so as a result, most of the students in the class are going to end up being graduate students, and they will all have had the first semester of graduate geometric topology. And just so that, you know, we're all kind of on the same page, I've made the first semester of graduate geometric topology as a prereq. And so that's why the prereq is a bit higher. So if you're looking for kind of like the more traditional version of Math 402, that's going to be Math 401, and that's going to be offered next year, or next academic year. And then I've gotten some comments about sort of if Math 401 should be offered in the spring or the fall, and it looks like Math 401 should be offered next spring, so that would be spring 2022. And that's because it will allow students to take the prereq, which is analysis 1, in the fall when it's offered, and so that they don't have to sort of scramble to fit it into their schedule. So I did get a lot of questions about, you know, why is Math 402 now got this like graduate level prereq? And, you know, that graduate level prereq, which is geometric topology, that's Math 444. So that's always taught in the fall, and that itself has like quite a few prereqs. And the most important prereq for graduate geometric topology is general topology, and that's being taught by Professor Sems. And so Professor Sems is great. He's a brilliant analyst, and he kind of, there's this really interesting phenomenon where topology, when you first learn it, it's like kind of an abstract generalization of analysis that you didn't really quite expect. And topology is really useful because it allows us to work with spaces which aren't smooth. So they could be pointy, they can be pathological. And that's very useful because, you know, in the real world, most of the objects we encounter aren't smooth and differentiable. They're, you know, kind of strange and weird, and you still want to understand them and classify them. And so Professor Sems is teaching general topology, which is Math 443 in this coming spring. And basically what he's going to start with is he's going to be generalizing the notion of continuity, and he's going to do that in terms of open sets rather than working with metric spaces and epsilons and deltas. And so if you go back to your, you know, epsilon delta metric space definition, you could actually talk about it in terms of open sets. It's just that when you talk about open sets in Rn, you would describe them in terms of epsilons and deltas. And so then sort of topology starts at this kind of really bizarre abstract notion of what is an open set and defining continuous function in terms of open sets, namely that you want the preimage of an open set under a map to be itself an open set, and then that's what you say is a continuous function. So I highly recommend, if you know you want to go further in geometry or topology or even in algebra, because algebra ends up using, there's a whole kind of area called homological algebra, and in that case you need what's called algebraic topology to make sense of some of the homological algebra. So I highly recommend, if you think, you know, really like math and you want to go further and you want to learn a bit more about geometry and topology, and you've got the prereqs, that you should go ahead and take Professor Sems's class. And oh, I guess the other thing to say about my teaching is that I'm going to be teaching sort of a hybrid in person. And what that means is that I'm going to pretend that I'm a TA. So I'm going to give kind of like a high level overview style lecture on an iPad, which I'll project to the board. So that way, if you're in person, you can see it. If you're remote, you'll be able to see my iPad screen. And so I'll give kind of like a high level 15-minute, overview. And then we're going to be, talking about that. And we're also going to be kind of working through some examples together so that we get an understanding for what is Morse homology? How do I compute it? What is the chain complex? Why is it important? And then rather than having exams, there's going to be weekly homework sets, but they're not going to be as intense. They're going to be just kind of like working out those examples that I started to do in class, or, the occasional kind of intermediate level proof. And then at the end of the semester, there's going to be presentations. And so that's going to enable graduate students and also undergraduates to kind of explore a little bit more within the realm of Morse homology and, connect it to research that they're doing with their advisor, or maybe, applications. So it turns out that Morse homology is used to look at CAT scans and sort of analyze CAT scans in a data analysis sense. So it should be a pretty fun class. And yeah, I love topology, and it would be great to have some of you. And if you're a freshman who's in honors calculus who's watching this, then you probably already know that I'll be teaching honors calculus in the spring. So somehow I'm kind of always either teaching multivariable calculus or honors calculus, and then I'm teaching like crazy classes that have like would seem like a bajillion prerequisites. But they both kind of tend to be really important, and a lot of the examples I use in my graduate courses actually come from multivariable calculus. And it turns out that having a good mastery of multivariable calculus really can take you quite far. So I'll end here, and we're at an hour, so it's a perfect time to end the Zoom video.